Hello everybody, thanks for staying tuned. Three-part series here on basic electrical circuits. And our first one was a series circuit, our second one was a parallel circuit, and this time we're going to wire a relay. And relays sometimes confuse people to how they work. People see them in vehicles all the time and they maybe understand that they're important for a circuit to work, but they don't necessarily know how they're wired. So I'm gonna slow down here from my last two videos, and we're gonna drag this one out a little bit longer and see if we can show you how to wire one and then how one works. Okay, we're gonna get started like we did before with a battery. Okay, and then we're gonna go through to a fuse. It's always best to have your fuse right away in your circuit. Now what I'm going to need to do is draw you a fairly complex diagram that is a relay. So I'm going to attempt to do this. And what I'm going to do is I'm going to draw the high current side of the relay first. I'm going to number this pin 30. And this is coming out of our relay. This is our box, our relay box. And I'm gonna number this one 87, okay? Power is gonna come into, fuse power is gonna come into 30, and you can see inside the relay that it's pretty much just a switch. When the switch closes, power is gonna flow out to, we're gonna do just a single light bulb on this circuit, okay? Back to the battery. I could add as many light bulbs as I want. I could make series and parallel circuits. I'm not going to attempt to do that here on this. Okay? Then I have two more terminals that we're gonna focus on here. And they're called 85 and 86. What it is inside 85 and 86 is an electromagnet. Okay, and quite often they're drawn something similar to this. What's going to happen is that I'm going to give positive to one side of my electromagnet and negative to the other. When I put positive on 85 and negative on 86, or vice versa, it does not matter. Polarity is not important on these two terminals. When I put positive on one and negative on the other, it's going to create a magnetic field which is going to close my switch. It's going to pull this down and close it, allowing power to flow through the circuit. So relays need to be switched on and on by a switch. I'm going to wire this one like this. I'm going to take 85 and I'm going to share this fuse with 85. And then what I'm going to do with 86 is I'm going to come out of 86 and I'm going to put in a switch. And then the other side of the switch is going to go to the negative of the battery. So what I've drawn here is power leaving through the positive side through a fuse. You could have two fuses if you wish, and those are going to feed the high current side of the relay on terminal 30 and the control side of the relay on 85. So both of them are going to get power at the same time. What's going to complete the path of electricity to my light bulb though is going to be me closing this switch, which gives 86 ground, because this is hooked up to the ground side of the battery. When I give this power and ground, I will create my electromagnet inside, closing this switch, allowing power to flow. If you watched my other two videos, you might be thinking to yourself, well, why did we complicate things to this bad? Why don't we just run power through a fuse, a switch to the load? And here's the answer to that question. This switch right here, running this electromagnet, has low current flow. The reason it has low current flow is this electromagnet only takes 0.15 amps to create the magnet. Okay? Stick with me here. Right now I have a load over here that happens to be a light bulb. The high current side this is the high current side that powers the light bulb, is going to, let's say, have 2 amps flowing through the circuit when this closes. So what relays do for us is they limit the amount of current that goes through our switches. So if you look on modern vehicles today, we have plastic switches, we have touch screens, we have circuits that are being controlled by computer circuitry. It's nice to keep the amperage low in all of that computer circuitry. It's nice to keep the amperage low in plastic made switches, so you don't have to have these heavy high amperage switches running your vehicle. Maybe you remember these things from the 60s and the 70s and maybe even parts of the 80s, where we had these switches that gave you that positive click, right? And they were hard to move. Other than that, the biggest problem with this circuit is that these switches burn out so much. I remember back when I was being a mechanic in the late 90s and I was working on grain trucks from the 70s and trucks from the 80s, we were changing switches all the time. Since they've switched over to relays, they've made themselves a very good connection in here that relays don't fail very often. So this can be switched thousands of times throughout its life and not wear it out. Also, because the switch has low amperage through it, the switches are lasting longer. The neat thing about this relay is it doesn't matter the size of the load that I put over here. If I increase this number to 20 amps, this relay can handle it just fine, as most of these relays are rated for about 30 amps. We have to build this now, okay? It was all right to draw it, but now we have to build it. So let's build it. The first thing I'm going to do is identify the pins of my relay. The way that I do that is with this wiring harness relay that I have here, I can just pull it apart. And you probably can't see it very well in the video, maybe you can, but this terminal here is labeled 30. This one is labeled 85. So when I know where the high current side is and where the low current side is, the rest is pretty simple. This is the start of the high current side, 30, so his friend 87 are over here. The low current side, here's 85, that'll make 86 over here. The middle on this relay is 87A. I'll give a quick explanation to it in the end, okay? It's just another out, another load supporting power wire. So, if you took this out of a vehicle, you wouldn't see the wires, you would just see this, but for today, I actually get to see the wires. So I'm gonna plug this in, and I'm gonna take a look that 30 lines up with blue, 85 lines up with white. And I'm gonna give these all a spot on my board. If you remember back to here, 30 and 85 both were protected by a fuse. So let's put